Bismillahirrahmanirrahim. Assalamu alaikum, students.
Alaikum salam.
Alaikum salam.
So last time we have started this chapter number 9. And in chapter number 9, what we have studied. The title of this chapter is Linear Momentum and Collision. This is the title of the chapter. So last time we have studied about the momentum. So in momentum, you remember that this is mv, and momentum is a vector quantity. And second, we have studied the law of conservation of momentum. Law of conservation of momentum. So law of conservation of momentum mean momentum before collision is equal to momentum after collision. The third is we studied the impulse. And impulse is I is equal to delta P. And this is equal to mvf minus mvi. And then we have studied the law of momentum, Newton's second law in terms of momentum. And that is F is equal to delta P over delta T. So this is called rate of change of momentum, but this is called change in momentum. So change in momentum is called impulse, rate of change of momentum is called force. Okay, then we have discussed different formulas of impulse, and graphically we have seen that f of t graph area under f of t graph will give you the impulse. So after this, now we are moving towards the collision. But before collision, you should remember that momentum is a vector quantity and it has the same direction as velocity. One thing. Impulse is a change in momentum, and this is equal to mvf minus mvi. And this is equal to mvf minus vi. So Vm minus Vi mean delta V. So impulse has the direction as the direction of change in velocity. This is very important when we solve the problems. Okay, let's see. I'm giving you one example to clarify this one. If we have this wall and a ball having mass m and velocity v is striking in this direction and then come back here. Okay. If their velocities and mass is the same, then what will be the change in momentum? This is important. So change in momentum is the final momentum minus the initial moment. So final momentum is what? mv. V is velocity. It is not speed, it is velocity. So it has direction in this way. If it has direction in this way, it is negative V. If it has direction in this way, it is plus V. So final momentum will be minus mv minus this minus initial momentum mv. So the total momentum will be minus 2 mv. But if the wall is in this side and the body is striking here and then moving back, then you will write the equation same final momentum minus initial momentum. So this will be minus mv and this will be plus mv because it is in this direction. So what will be the change in momentum? So change in momentum will be mv minus of minus mv. and this is equal to 2m. So you should remember this one. And similarly, if the ball is falling down, we are taking minus. If the ball is going up, we will take plus v upward and minus v downward. And same notation we will use like this. Okay. After this, now I'm coming towards the Coulomb. So the momentum, change in momentum, impulse, Newton's second law in terms of momentum, finish. Now Coulomb. So in Coulomb, what is Coulomb? A Coulomb is a short duration interaction. If the interaction is for a short time, then it is called Coulomb. Like a tennis ball strikes to the racket. Its Coulomb is for a very small time. So the small time mean it is a delta t time and it will be in millisecond. It can be in millisecond, microsecond like this one. So if we plot a graph between f and t, and this graph is showing what? This graph is showing that this is the point of contact begins with the racket. And this is the point of contact ends from the racket. And this is called the maximum compression force the ball have. And this is the time, delta t time. And this delta t time is in millisecond or microsecond. So last time we define impulse. Impulse is I. It is average force multiplied by time and delta t time, or delta p, or mvf minus mvi, or the area under f of t graph. This is impulse. But if I'm writing here impulsive force, then it is different than this one. Impulsive force means if the force is acting for a very, very short time, then that force is impulsive. So impulsive force means large force as compared to other forces, large force for short time. Then this force is called impulsive force. But impulse is different than impulsive force. Okay, after this. Now we have a Coulomb. Two kinds of Coulombs we are discussing. One is called elastic Coulomb, and the other is called inelastic Coulomb. So I'm just defining here elastic Coulomb. Elastic Coulomb is that Coulomb in which the momentum and kinetic energy remains same before Coulomb and after Coulomb. Remain same. So momentum is that term which remains same in any Coulomb. The second is inelastic Coulomb. Inelastic Coulomb is that Coulomb in which momentum remains same before and after Coulomb, but kinetic energy does not remain constant, does not remain same, does not remain same or constant. So this is called inelastic Coulomb. But we will more focus on elastic Coulomb in one dimension and elastic Coulomb in two dimensions. Okay, after this Coulomb is perfectly elastic. Perfectly elastic means the shape of the ball is deformed, but it retains after Coulomb. It is called perfectly. So here we are seeing some terms. If one body is colliding with this one and their center of mass is here. Center of mass means where the whole mass is acting or whole weight is acting. and they are in a straight line, they are colliding with each other, then this collision is called head-on collision. It is called head-on collision. But if the collision is like this is a billiard ball, and you want to make this ball in this direction, and the other ball is going in this direction, then this collision is called oblique collision. This is called oblique collision, but we will normally study this. Okay. Now I want to discuss with you the elastic collision in one dimension. So in one dimension mean that the body is moving in a straight line. So suppose this m1 and this is m2, its velocity is v1, this is velocity is v2. They are colliding with each other, and after colliding, they are moving in this way, not in this way or this way. They are moving in the line, on the line. That's why it is called one dimension. So after colliding, their velocities surely will change, and this is m1, this is m2, it is v1 dash, this is v2 dash. Dash mean change in velocity. Now we want to find this v1 dash and v2 dash. This is our target in this article. Here in the book, they have written in the direct form the equations, but here I will solve it and you will see how the things are changing. So collision is elastic. It means momentum and kinetic energy remain same. Momentum mean mv, kinetic energy mean half mv square. Both remain same before collision and after collision. So this is the position of before and this is the position of after collision. So what I will do, I will write the equation before collision. Total momentum before collision. Total momentum mean m1 v1 plus m2 v2. This is the total momentum before collision is equal to total momentum after collision m1 v1 dash plus m2 v2 dash. So this is the momentum before collision, this is momentum after collision. Now I want to, this is equation number 1. I want to rearrange this equation m1 v1 minus m1 v1 dash is equal to m2 v2 dash minus m2 v2. So you can write this equation in this form, or you can common m1 and m2 from here. This is equation number 2. Now here, the momentum game finish. Now the game is starting about the kinetic energy. In the next slide, see the kinetic energy. Kinetic energy before collision, m1 v1 square plus m2 v2 square. This is the kinetic energy before collision, and this is equal to the kinetic energy after collision, v1 dash square plus m2 v2 dash square. So what you will do, you will cancel this 1 over 2, 1 over 2, 1 over 2 throughout. This is m1 v1 square plus m2 v2 square is equal to m1 v1 dash square plus m2 v2 dash square. You can write in this form. Now I rearrange this one like in the previous slide. m1 v1 square minus m1 v1 dash square is equal to m2 v2 dash square minus m2 v2 square. Now I make common v1 square minus v1 dash square is equal to m2 common v2 dash square minus v2 square. So I can make it v1 minus v1 dash into v1 plus v1 dash. So I apply the formula a minus b into a plus b is equal to m2 into v2 dash minus v2 into v2 dash plus v2. So my equation is number 3 is this one. Now what I want to do, I want to divide this equation by equation number 2. equation number 2, you should remember that this is our equation number 2. So left hand side on left hand side, right hand side on right hand side. So what you will do? You will divide it m1 v1 minus v1 dash and over m2 into v2 dash minus v2. So this will cancel, this will cancel, this will cancel, this will cancel. So we have v1 plus v dash is equal to v2 dash plus v2. Now we left only this portion. You don't need to make this calculation. I just want to tell you how the equations will come. This is my target. Otherwise you cannot understand this one. Okay, so here you can see that v1 plus v1 dash, v1 plus v1 dash is equal to v2 dash plus v2. I rearrange this equation that v1 minus v2 is equal to v2 dash minus v1 dash. So this is showing, this part is showing that the balls are approaching with this velocity, and after colliding they are separating. This is actually the difference in velocity of approaching, and this is the difference in velocity of separating. So anyhow, you should just remember this one. Okay, now what I want to do, I have equation number 1 in the first. This is my equation number 1, m1 v1 plus m2 v2 is equal to m1 v1 dash plus m2 v2 dash. This is my equation number 1. Now I want to find v1 dash and v2 dash in terms of their masses. This equation is not in terms of their masses. So what I will do, I will put v2 dash value from here is equal to what? v1 plus v1 dash minus v2. I will put this v2 dash in equation number 1 and then find the v1 dash value. How? See, this is a little longer, but you should remember the direct formula. m1 v1 plus m2 v2 is equal to m1 v1 dash plus m2 into v2 dash. So v2 dash is this one. It is v1 plus v1 dash minus v2. Now you can rearrange this equation. They will not cancel. Any equation will not cancel. m1 v1 plus m2 v2 is equal to m1 v1 dash plus m2 v1 plus m2 v1 dash minus m2 v2. Now you can see I need v1 dash. So where is v1 dash? v1 dash is here. v1 dash is here. I need this one. So what I will do, I will make it v1 plus m2 v2, the other equation, this and this on this side. So this will become m2 v1 plus m2 v2 is equal to, from this and this, I will take common v1 dash and m1 plus m2. This will become. Now, what I will do, I just rearrange this one. So I know m1 v1 and m2 v2, m2 v2. This is m2 v2, this is m2 v2. What will be? So 2m2 v2. My answer will be 2m2 v2. From this and this, I will take common v1. I will take common v1. The answer will be inside. This is m1 minus m2. And this is equal to v1 dash into m1 plus m2. Now, I divided it by m1 plus m2. So what I have to do, I'm writing here because in the next page may be difficult. So this is v1 dash is equal to v1 into, I'm writing first this one, v1 into m1 minus m2 over m1 plus m2 plus 2m2 v2 over m1 plus m2 divided it by whole m1 plus m2 and m1 plus m2. One for here and one for here. So the question is, when two bodies are colliding each other, then after colliding, their velocities becomes like this one. So I am just writing this equation in the next page, that this is v1 dash is equal to what? v1 dash is equal to 2m2 v2 over m1 plus m2 plus previous slide v1 into m1 minus m2 v1 into m1 minus m1 minus m2. So m1 minus m2 over m1 plus m2. Our one equation is this one. Okay, now I'm writing the second equation. The second equation will become what? If I find the v2 dash value after solving this one, then I will get 2m1 v1 over m1 plus m2 plus v2 into m2 minus m1 over m1 plus m2. So these are the equations which is very important for problem solving. So you have to remember this one. What are these equations? If we have two bodies, they collide with each other in one dimension. They collide with each other in one dimension. Then after colliding, what will be their velocities? We will find with these formulas. And sometimes they put the conditions that the second body is at rest, then surely V2 will be 0. And sometimes they put the conditions, if M1 is equal to M2 is equal to M, then what will be V1 dash and V2 dash? So these are the conditions you can solve yourself if M1 is equal to M2 is equal to M and V2 is equal to 0. So just put here V2 is equal to 0, this will cancel, this is 0. And M1 is equal to M2 is equal to M. So when you put here, then V1 dash will be 0. So total 0. And when you put here V2 is equal to 0, then this will cancel. But this will not cancel because it will become 2M over M plus M, 2M. So 2M will cancel with 2M and V2 dash answer will be equal to V1. So in the same way, if M1 is very, very greater than M2, it means that M2 is approximately 0. Then we will put M2 0 and V2 0. Then what will be V1 dash and V2 dash? So we can solve this one. Now it depends on the conditions, which conditions are given. So according to those conditions, we will solve the problems. And this is our elastic collision in one dimension. So here I explain you that if two bodies collide with each other, after collision, what will be their velocities? How you can find the velocities? But the collision is elastic and it is in one dimension. So remember here, these equations are valid only for elastic collision and in one dimension. So you can solve this one. Okay. After this, now I am going the elastic collision in two dimension. So in two dimension mean what? The same, the two bodies, they collide with each other. After colliding, they are not moving in the same straight line. One body is moving in this way and the other body is moving in this way. So how we can solve the equations? So to solve the equations, what we will do? This is suppose M1 and this is U1 initial velocity. This is M2 and U2. They collide with each other. After collision, they should go in this path, but one is moving in this way and the other is moving in this way. And this is making an angle θ1 and this is making an angle θ2. So momentum is a vector quantity. So what we will do, if I'm saying that this is m1, its velocity is v1, and this is m2, its velocity is v2. So you will make the components like this one and this one. You will make the components like this one and this one. Okay. So here in the upper portion, if I want to write the momentum along x-axis momentum, x-axis mean in this direction. So it will be m1 u1 plus m2 u2. This is before collision. And after collision, it will be, this one is m1 v1 cos of θ1, because this component is cos of θ1. m1 v1 cos of θ1 in this triangle. This is θ1, this is m1 v1, and this will be m1 v1 cos of θ1. So plus the same component is for this one. If I take this triangle and this is this one, this is θ2, then this will be, this is m2 v2, then this will be m2 v2 cos of θ2. So I write here m2 v2 cos of θ2. One thing. Now the momentum along y-axis, because it is two-dimensional, y-axis. So y-axis momentum is here, y-axis is 0, here y-axis is 0. So 0 plus 0 is equal to, here y-axis is this one. This is your y-axis momentum. It will be m1 v1 sine of θ1, and this is downward direction. This direction is downward. m2 v2 sine of θ2. So we can write m1 v1 sine of θ1 minus m2 v2 sine of θ2. So this is our second equation, momentum along y-axis. Now, if I want to write, this is the game of momentum. So momentum game finish. Now the game of starting kinetic energy, because the collision is elastic. So kinetic energy is not a vector quantity. It is a scalar quantity. So we will write only one equation for kinetic energy. So for kinetic energy, it will be 1 over 2 m1 u1 square plus 1 over 2 m2 u2 square is equal to 1 over 2 m1 v1 square plus 1 over 2 m2 v2 square. So you can simplify this equation by cancelling this 1 over 2 throughout, and then you can write this equation. So this is called elastic collision in two dimension. So elastic collision means if the momentum and the kinetic energy both remain same, then the collision is elastic, and this is called perfectly elastic. Perfectly elastic means it is deformed but retain after some time. So this is the article, elastic collision in two dimension. So next time we will discuss the perfectly inelastic collision, and then this chapter theory finish. And we will solve the problems of chapter number 9 about the impulse, about the momentum, about the law of conservation of momentum, and about the Newton's second law in terms of momentum, and then collision, elastic collision, inelastic collision, like this one. Okay, so see you in the next lecture with inelastic collision, and we will solve the problems.
Doctor,
Yes,
in your office hours, when will you come?
I come at 7:30.
All day?
Yes, and go back at 5 o'clock.
Okay, what's your
Only
office number?
from 8 to 12, I am busy. I have classes. After 12, I am free. But Just this salah time and the lunch time, and after lunch time, after 1 o'clock, you can come.
What's number?
1A57.
Okay, thank you.
Yeah. Okay, inshallah. See you in the next lecture. Okay, assalamu alaikum.